right. Okay, so here again, this is a word problem from the textbook, actually. So again, the blood pressure, I'm not sure how to pronounce the first word, of males, we're told, has a normal distribution, okay? And it's about, and with a mean of 125, and the standard deviation is 14. What we want to do now is find the blood pressure of a man whose z-score is 0.75. So in other words, if the z-score is 0.75, what's the blood pressure going to be? So in a sense, we're not going from data values to z-score, we're going the other way. No big deal. So here we're basically being given a z-score. We want the corresponding data value. Okay, so let's do that. We have 0.75 equals the x minus 125 over 14, right? And now we're going to solve for x. That's what we're doing here. That's what we're doing here. All right, so let's do that. Let me get the pen. Here we go. So again, let's first get the denominator out of there. We actually have done this kind of problem before, right? First, we want to get the 14 out of there, the denominator. All right, no big deal. Multiply both sides by 14, right? These cancel, and we're left with this, right? 0.75 times 14, excuse me, is 10.05. So that's equal to x minus 125. We want x, right? Okay, so let's add 125 to both sides. These cancel. We get x all alone on the right. On the left side, we get 135.5. Okay, we'll just see some. Right, we get 135.5. Okay, good. So that tells us the blood pressure, a person's, the data value that corresponds to 0.75, right, is 135.5. Now, is this unusual or not? Well, remember, for a data value to be unusual, its z-value has to be greater than 3 or less than -3. The z-value must be bigger than 3 or smaller, that is more negative than -3. That doesn't happen here. The z-value is 0.75, so this is not unusual, this blood pressure. Okay, that's good. Remember, the z-value tells you how many standard deviations a data value is from the mean. So that's for this problem. For the next one, it's similar, except now our z-score is 3.2. So we're finding the data value whose z-score is 3.2. Okay, so what's that going to be? Well, it's just like before. We're going to solve for it. We're going to solve for x. Oh, sorry. I pressed the wrong button. I wanted to get this pen thing and I pressed the wrong button. Sorry about that. Let's just see, actually make sure that, can everyone still see it? Yes, okay, good. Okay, just want to make sure everyone can still see the slides. All right, so now, right, so we're going to solve for x. That's what we're doing. Okay, so just like before, it's really the same steps as before, right? We're multiplying both sides by 14. That kills off this denominator. You know, we want x to be all alone. So this is what we get here. The left side, you just multiply, you know, like you normally would. Next, to get x all alone, we have x minus 125. We want x all alone, so we add 125 to both sides, and that's what we're doing here. These cancel. We get x all alone on the right, and on the left, we get negative 179.8. So the blood pressure that corresponds to a z-score of 3.2 is 179.8. That's what we get. Now, is this unusual? Well, yeah, right? Because the z-score is greater than 3. Remember, if it's greater than 3 or less than negative 3, that makes it unusual. Mostly because it's more than 3 standard deviations from the mean. So that's what happens. So that's for A and B. For C now, we want to know what percentage of males had a blood pressure less than 160 millimeters, excuse me. Okay, what percentage of males had a blood pressure less than that? So percentage of data values, right? You want area. So let's get the z-score, which is what I'm doing here, right? So here we have our data value, so we calculate, subtract the mean, divide by the standard deviation, and we get 2.5. Now again, the table you should have in front of you, so I'm not going to jump to the table now. But basically, if you looked in there, you would get 0.9938. In other words, the percentage of males that have a blood pressure less than 160 milliliters, would be about 99.38%. Again, percentage, right? So we first get the z-score, which is what we're doing here, right? Then from the table, we get area, and then we just multiply by 100. That's all it boils down to. I know it seems scary, I understand that, but it's really not as bad as it seems. Any questions on that? Now, let me ask it this way then. Really hope it makes sense. I really want everyone to do well. I know this is an online environment, so that's probably making it more stressful for everyone and more harder, but I really want everyone to do well. All right. I really hope it is. All right, good. Okay. All right. Well, let's keep going then, okay? All right. So we're going to keep on going. Again, this is the last chapter, so once I'm done with chapter 12, which if not today, then it'll be Tuesday after break, I figured we'd do review problems for the rest of the classes. All right, so let's keep going. All right. So from the table, right, we were able to get the area to the left of the z value. Okay? We were able to get the area, that lies to the left of the z-score. And that's useful because if we wanted the percentage of data values less than, a data value, we get the z-score and get that area, the area that's to the left. But what about the area to the right, though? What if we want the percentage of data values greater than something? Well, can we do that? Well, you can tell from the slide that, yeah, we can do that. Basically, what's going to happen is this. The total area, remember, under the graph is 1. I've told you that today. It's also up here, but the total area is 1. So if we want, let's say, this area here, which is the same as this area, what we can do is throw away what we don't want. So we're basically eliminating what we don't want, and what's left over is what we do want. So we're going to throw away the area to the left of that z-score. What we're left is the area to the right. But wait a minute, how do you throw it away? How do you throw away that area? Well, you subtract it from 1. Since the total area under the graph is 1, if we subtract this off from 1, from the total area, we're left with this piece, which is the same as over here. So all I'm trying to say is we subtract the area from 1 to get the area we want. So if we want the percentage of data values greater than something, what we do is we're going to subtract the area from 1. That's what we do.